again, Donald. So I don't know if you guys remember this from the last video, but this is his actual Messenger M4v. The other one was the 2000 watt Messenger that I just did. And we're going to attempt to replicate that. I've been pulling parts out of this like it's going out of style. This fuse holder that was in it was missing a cap. That doesn't matter because, well, the fuse holder was broken. I took all the power wires off because we're going to change those around. This board was actually kicked forward to where it was almost flat, and I'll show you here with a picture. So now I got to take this board off, because if you can see down in here, you can see that relay. The whole back end of it's broke out. Now, he made some comments to me on the phone about how the low, medium, and high gets so hot the front of this box you couldn't even touch it. I took all that horse shit out of here. Why? Because I don't want to have any of this heavy crap hanging on the back of this board. It's not needed anymore. For you to leave the low, medium, and high in here and run this as a straight, god damn it, run this as a straight 8-pill is really silly. So let's trace the circuit out, you guys. The RF comes in, runs across, goes through the low, medium, and high, and then somebody, instead of having it hooked up over here, just simply pulled the wire over and attached it to the input splitter for the 8-pill section. That's a problem, because all the drive, which is 400 watts, has got to go through the low, medium, and high board. That's too much wattage for this little tiny board to handle. That's the reason it kept burning up resistors, and they had to start stacking up crap like this. If you want to adjust your dead key, you do it at the radio. Hence the reason the low, medium, and high board in the stock configuration for an M4v, the RF power comes in from the coax connector, runs across the amplifier, goes to the low, medium, and high board, then comes back and goes over here to the input circuit for the driver section. Well, as we can see, there's no driver pill in here. Now, the other thing that they did is they left the driver section hooked up. As you can see, this is still soldered in and still very active. So this whole circuit, capacitor, tuning coil, transformer, extra coil to ground, is still active in the drive circuit, on top of them running it through the low, medium, and high board, which, because they don't have the right kind of attenuation or the right kind of resistor set up, the low, medium, high board anyhow is more or less just a voltage divider. So in an effort to make this right, we've got to disconnect this 2-pill section, the driver section here, but we are going to use that driver section here in a minute. I'm going to bring this whole tuning portion of it into play. We're going to have to change the output coil. I removed the positive rail already. We're going to need to change out these wire wound resistors, which I do believe these are wire wound. Anyhow, you can't use wire wound. You got to use like metal oxide, something that it doesn't have a wire in it, carbon pack, something like that. Change out all these caps, add caps here, and then I've got to go through and I got to neaten up all this stuff, like this loose 10 ohm resistor, and clean all this up. And then I got to clean all this solder mess up. Once we get that done, then I can go and put the new transistors in it. But on a positive note, it does happen to have all of its screws in there. So when I come back, this is all going to be cleaned up. We're going to have new power wire, new distribution bar for the positive rail, new resistors. There are no flyback resistors that are left in this box. They've gone on to God other places. This section will be bypassed from here down. This will be in play, and we're going to use it. This is pretty important how we use these coils. Actually, I got to take this coil off and make a new one out of new mag wire, and the same with this one over here in the corner. But first, like I said, I straightened this out for the most part. I'm going to come back and straighten it out some more. I've got to disconnect this board thoroughly from the unit, replace that relay, test this relay, put this whole thing back together. But before I do that, I've got to go down in here and I got to change this coax. Somebody came in here and they used, this is like RG58. This will not put up with the heat this amplifier is going to produce. It's solid core, which is not what you want to use in a mobile application. So we'll put like RG400 in here, which can actually handle the wattage that we're going to make this previously like 1200 watt box do. We're going to make this thing do, hopefully, if everything works out correctly, this thing should do about 2200 watts when we're done. Well, the other thing is that they got the bias They removed the jumper wires that go from the bias circuit from here to here to here to here to feed the bias, but they left this ungrounded, so now this is running in some Quasimodo form of Class C. I've got to take these coils, I got to ground them, so I'll probably build new chokes for those. But this one transistor, this one 2-pill bank, has still got bias on it. Because this is the switch 12-volt lead that comes in, this is your load resistor, and then off of here, down this trace over here, they've got a diode, which I've got to pull that diode out too. Here's the remnants of a flyback resistor. Oh, and I got to clean up all this trace work. And I'll straighten out the front end of this box, and we'll make it all right. So Donald, wish me luck. Because this thing has seen better days. Oh, I dug around and I had another messenger here that took the actual ferrite rod out. This is out of like a Texas Star, and somebody had stuffed it in here. They managed to bust the trace off the board, and then they had this bent and they had it soldered on here, which is not the proper fix. The wire is too small and won't carry enough amperage, so I'm going to repair that as well. On that note, I'm going to wash the box, and we are going to fix some of the smaller fuck-ups in here, so I shall return. So I had to make a choice. You gotta make choices like this when you're doing this kind of repair. All those traces have been pretty fatigued. Now I'm gonna go back and I'm gonna re-slobber them and resolder them all up, but I decided instead of trying to fatigue the traces anymore, it'd be easier just to take the back off the box and sneak this relay out. And it's just hanging on there by a thread. Sneak this relay out, and I'm kind of second guessing that one too. It looks like it's been pretty beat up too. I don't know where the back of this went because it wasn't inside the amp, but I figured while I was back here I could replace this little shitty breakdown at 400 degree, 300 degree temperature coax. We got a lot of the other parts out that, well, they're questionable, and got ourselves ready to ground these things. Took all the 10 ohmers out because, well, half of them weren't soldered in properly, and the traces on this thing are just, they're out of this world. But then again, we're talking to Mr. Crap Rebuilder. I can take something like this, and if the guy wants me to pay me enough money, I will make it look like brand new. So, all right, I'll pull the traces apart next, or the relay apart next. I'm gonna finish taking the back of the amp off. Hopefully, get this bent out a little bit more straight. And oh yeah, the other thing I noticed is that we're missing a pin. There's supposed to be 6 pins in this thing. That pin is gone, and the wire that it attaches to is also gone. It's supposed to attach there. So, I don't know. I'm going to dig around and see if I got another one of them pins. I don't think I do. But, long and the short is I'll make this thing work. So, next step is going to be dismount relays, dismount the back, and then I'm going to wash it. And then after I wash it, then I'm going to do the process of rebuilding the traces. I don't think I'm going to use these traces anymore. These are pretty not held down by anything. The flybacks attach on most of these, which would be an electrical RF safety hazard. So probably going to have to abandon, if not remove, most of those traces. But we'll get this thing cleaned up. I got this section bypassed. I simply moved that wire and grounded it. Like I said, I'm going to pull this coil out and change it, and then we'll pull this one out and change it eventually too. But, all right, on to the next step, making it pretty again. It's a skeleton of its former self. Well, $30-some worth of chemicals later, an electronic wash, and scrubbing, and more scrubbing, and, God, more scrubbing. It's back in a position where we can start building it back up now. Jesus. Anywho, all the flux is off, the coils are off, coax is off, relays are out, board has been resoldered. It's now held on by more than just a hair. We didn't end up losing any of the traces off the relay board, which is commonly the problem. We got rid of a lot of the disc capacitors, so as I go and I reattach the transistors, I'm going to clean up all this solder mess, and this will look pretty close to stock when I get done with it. This section of it anyhow. Yeah, I'm going to take this burnt broken, ripped up, traced mess and clean it all up. Yeah, I'm going to add a power distribution mirror board over here, or not mirror board, but distribution board over here. And okay, now we're going to go and put her all back together. Just had to take a few parts out of it. This, I don't understand how this happened. I mean, somebody got in there and reefed on that with a screwdriver. They started a process on this one, so I don't trust this relay. And even at $6 a piece or whatever those are, I'd rather just replace them. Okay, on to the next step, putting it back together. Well, this was entertaining. Well, I had to change a few parts. I spent 2 hours just doing trace repair work around the transistors. This, by far, was the worst messenger that I've ever gotten as far as it being chopped up. And the customer didn't want to abandon it and move on to something else. But here's the after. Copper distribution bus. The relay board's in there straight now. All the traces attached to the relay board have been repaired. 2 new transistors. Took the back off. Thoroughly washed the box. Fully repaired. Put power to it and key it tomorrow. It is 2:30 in the morning. I am tired. And I'm going to bed. It's a sexy bitch. Now, anyhow. Let's see if we can make it through this video without the phone ringing. And I'm telling you guys, I can't even believe this is the same amplifier. Uh-oh. There, now it's square. I mean, this thing was so boogered when it got here. But now it's all good to go. So, we're going to do this thing in a couple different stages. Let's see. Let's turn that on to 1. Peak on. This is 1X. 1000 watt slug in 1. 1000 watt slug in Av. 5 watt slug in reverse. 50 watt slug between the 2-pill and the messenger. And let's see. Let me reach down here. Turn on them power supplies. So anyhow, we added a couple fans to it to help keep it cool. Now the transistors that we used inside of this thing are, well, we're not going to say. They're not Toshiba's. We'll say that much. Anyhow, we're going to see about 1600 watts out of this box when we drive it hard. I set it up that way. I took it out to 2000 peak, which was about 800-900 bird, and then I dialed it way back. Because remember, this is going to the same guy that told me now, BBI. You gotta remember, I got a little long-winded. Okay. So we're set up for that. Let me show you the performance of this thing. You're gonna love it. So first, off, and off. 20 watts of drive. 2290. 5 watt slug and reverse. Between the 2 pill, talking into the 8 pill. Going in and around the corner and out to the dummy load, right? Nothing to it. So with 20 watts of drive, about 100 bird, about 500 watts. So let's shut this back down. Now he says he's got himself like a little JB12 or something that he's going to hit it with. So basically like a little 1 pill. Now I've got the 2950 turned down pretty far. And I mean pretty far. Let's back that down some more. Nope, still too much. Audio. I'm gonna put about 40 bird in it, you guys. Watch what happens now. 200 watts peak, 40 bird. We're gonna take this up to the 2x position. Check this out. That's a 40 bird of drive, making 200 bird now, and about 1400 peak watts. Now, if you run this thing just like this, set this thing on its roof, it's never going to get hot. Those little fans chooching, you're going to be able to sit there and talk on this thing till the cows come home. Now, what I can do, I'm going to reach up here and we're going to turn that mic gain up. Bring this back down to 1x. Audio. About 400 watts peak. Audio. And about 100 bird. Back up to 2x. Just by increasing the drive, now we're getting 400 or 500 bird out of it. You really step on it, you get it to do 1600, 1700 all the time. It's in Class C, and you can run the ever living brakes off of this thing. Now the reason I got to set it up like this, you guys, is because he's going to drive this with an unknown. Okay, I could take this thing to where it does a ton of watts, but that's not safe because now he's going to drive it with an unknown box. I don't know what he's got. So to play it safe, we're going to set the amp up to do X amount of watts, do an X amount, do an X amount, X amount. Okay, got it? A little bit low on input power. Let's take a look at our input reflect. Remember, this is talking through a 2-pill. So now let's set our 2-pill back up. Boop, boop. Set our 2-pill back up for only about 200 watts of drive. Nope, there's 4. Audio. Still 4. Audio. Okay. Got our 200 watts back. It's back up to 2x. And we're going to hit this with 200 peak watts. 200 peak watts, about 50, 60 bird. Audio. Here's our input tune again. Hello, audio. Hello, audio. 200 watts going in, maybe a 1.5 watts coming back. You're done, brother. I'm going to put a bow tie on it. We're going to send it home. I got one more for this guy that I'm going to try and get done this weekend, but I got to do a bunch of other repairs. I've spent a lot of time on this just for the fun of it. It's all finished, and it's ready to go. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud dog in Idaho. Come check us out, www.bbimps.com. Come find me on Facebook, Twitter, Snapchat, Instagram, and right here on the uGargler. Make sure to click subscribe right down there, I think. On to the next one. Another dude, 10-8 and straight. Click, click. Now, Donald, I don't want you to freak out, buddy. You asked me to send back all the parts that I took out, which they don't mean nothing to me, dude. So we're going to send everything back to you, including the busted up preamp relay and the busted up transmit relay and the bias resistors and the broken air variable. That's mine. I'm going to send you all this back, plus all the power cable. I know, including the ends, and the heavy duty wire and stuff. I'm going to throw it all in here, and we're going to send it back to you. So don't worry, buddy. I didn't forget. I'll see you guys. Bye-bye.